Hello, I am Jack Ingram, and this is my Lab 1 on constant velocity. The introduction. So in Lab 1, we are tracking the motion of a ball in one direction at a constant velocity. We will find the distance the ball traveled and the time that elapsed in order to find the velocity of the ball. Since we are assuming that the ball is traveling at a constant velocity, we assume the acceleration to be zero. We can use this information along with Newton's second law, which states that force equals mass times acceleration, or F equals ma, to show that there is no zero net force on our ball as it travels. We will also build a computational model to predict the distance the ball will travel and compare the results of the model with our observations from the trial. For this lab, we will be tracking the motion of this soccer ball. After uploading the video into Tracker and setting the proper coordinate system and frame rate, I tracked the ball using its center of mass to follow its position over time. Using the data from Tracker, I was able to make the following calculations. The ball rolled for 1.568 seconds in the observed frame, traveling a distance of negative 3.73 meters in the x direction. At time t equals 0 seconds, x was at 0 meters. At time t equals 0.1 seconds, x was at negative 0.240 meters. Using the delta v formula listed here, we were able to find the velocity as being negative 2.40 meters per second. The next step in this lab was creating a computer model. To do this, we started with the example code from Canvas and then made some changes, including changing the pre-existing conditions to match my trial and changing the equations under the while loop. So if you see here to the left, we set the initial position of the ball to be effectively 0 and the velocity of the ball to be that negative 2.4 that we just calculated. And we set our delta t to equal the time increment we used in Tracker. We also updated the velocity formula to use Newton's second law. So here's my GlowScript code, and if we run this program, you can see this is a depiction of the soccer ball moving from right to left, and this graph shows the position versus time that the code generated. So here's a side-by-side look at the graph generated by Tracker and the graph generated by the GlowScript code. As you can see, they look very similar. They both have a negative slope. The Tracker code did not generate a perfectly straight line, and we'll talk about why that is a little bit later. But the GlowScript code did generate a straight line because it was just taking in that same velocity and that same increment of time. This graph shows both sets of data on the same chart. As you can see, the model is in red and the observed data is in blue. And at the beginning, they seem to be very similar, but as time goes on, they seem to split away. And the model predicted the ball would have traveled further in the observed time than it actually did. And we'll talk about the reason why that might have happened in the next slide. So what were some of the differences between the model and the observed trial? So the model predicted that the ball would travel a distance of negative 3.74 meters, but in actuality, the ball only traveled negative 3.37 meters. One reason is the ball did not have truly constant velocity due to friction and other outside forces not accounted for by the model. The ball also likely had a z component during the trial, meaning it was not traveling in a truly straight line. It is also unlikely that I placed the point mass indicator exactly in the center of the ball every time, which could lead to more error. What if we had used a different coordinate system? So the chart on the left is what Tracker gave us, and this was using the positive x direction going to the right. But if we had swapped it and made the positive x direction going to the left, we would have ended up with the mirror image of our chart, which you can see to the right here. What if we had used a different coordinate system? So the chart on the left is what Tracker gave us, and this was using the positive x direction going to the right. But if we had swapped it and made the positive x direction going to the left, we would have ended up with the mirror image of our chart, which you can see to the right here. Hello.
Thank you for watching, and I hope you are all staying safe during these crazy times.